Hi, I'm Chris.
And I'm Sean, and this is Weather Booth.
The light is greater than that of the moon.
So, Chris, we did another episode.
I
We're on
know.
episode 2 of season 2.
Another episode. You mean season 2? That's 2 twos. That's
I
too
know,
many
like,
twos.
that's too many twos.
I know.
Anyway, so what are we talking about today, Chris?
It's a really good question, Sean. Today we're going to talk about the sun. And in order to understand the climate, we need to understand some facts about the sun. So here are some facts about the sun. I've done the math for you guys so you don't have to do it. So first thing, the sun is kind of large.
How big is the sun?
The sun is 6.07 times 10 to the negative, or not negative, positive 18th meters squared. And just to get a sense of how big that is, for our American audience, that is 1,134,329,809,538,681.5 football fields. To put that in comparison, Earth can only hold 95,305,456,815 football fields. UAlbany can hold 461 football fields, surprisingly.
And on none of those football fields are the Patriots a good team. Well, subjectively.
Not anymore, that's for sure. So that means for every football field on Earth, there are over 11,000 football fields on the sun. So, real estate market would be on fire there, literally. But jeez. The sun is also relatively warm, at least compared to Earth. Now, some portions of Earth can actually be hotter than the sun, particularly in lightning strikes and atomic bombs. The sun's average temperature is a mild 5,500 degrees Celsius, or 10,000 degrees Fahrenheit. And climatologically, according to Earth seasons, it does not vary that much. This dwarfs the Earth's average temperature of 15 degrees Celsius, or around 60 degrees Fahrenheit. The average radiation emitted from the sun, it would be far too overwhelming for any life to sustain. Luckily, only 1/1,000,000,000th of the energy from the sun reaches Earth.
Ooh, so you need some extra sunscreen if you were to live on the sun.
A little bit, a little
Okay.
tiny bit, maybe SPF 50.
Yeah.
On top of that, about 40% of the energy that reaches the top of Earth's atmosphere is deflected. So, while the sun's overall temperature does not have a climatological seasonal cycle, there are some features that cause variation in the sun's temperature, among other properties. One of these features are sunspots. Now, sunspots are spots that we can see on the sun, and they are significantly cooler than the sun itself, only around 3,500 degrees Celsius, or 6,000 degrees Fahrenheit. We can actually see sunspots because they emit a different visible wavelength of light than the sun. They're caused by something called the magnetic field flux, which is just fancy talk for complications of the magnetic field. And these can cause huge solar flares, which Sean is going to talk about in a little bit. However, these also have minuscule effects on the radiation that reaches Earth. So, what does the sun actually do to Earth? And the answer is a lot. Without the sun, life would cease to exist. We feel the sun's radiation on nice, sunny days. Sometimes we can be caught without sunscreen, and we suffer yearly on the late spring warm when we realize we forgot to bring sunscreen to our friend's graduation.
Personal story?
Multiple personal stories. The sun is responsible for heating up Earth during the day, and its energy leaks from Earth overnight. Actually, any object with a temperature emits radiation, so Earth's outgoing radiation is equal to 1/1,000,000,000th of the sun's radiation, as I mentioned before. Now, Earth's orbit around the sun is not actually a perfect circle. It is slightly elliptical, or shaped like an oval. And the Earth is actually 5 million kilometers closer to the sun in January than it is in July, although it doesn't feel that way around here. That's a minuscule distance compared to the actual distance from the sun. Overall, Earth has a very constant temperature. Obviously, there's temperature swing between day and night, but Earth has gotten to a point over time where there's what's called a general energy balance between the incoming solar radiation and the outgoing long-wave radiation. As Albany residents, we feel as though there are energy imbalances, specifically through our seasonal cycle. Some other examples of anomalies include cloud cover, cold frontal passages, and very slightly through climate change, which there has been a 1 to 2 degrees Celsius global warming over the past 100 or so years. And in addition to the weather we know, there's also space weather. Sean, what can you say about space weather?
Well, to start off with space weather,
Space
just know you don't need your
weather.
galoshes or umbrella for this story. Instead, you're going to need a radioactive protective magnetic shield.
Ooh.
You got that in your itinerary?
No, not yet. It will be in my Amazon cart soon.
That's good. It'll be next day delivery?
Next day delivery.
That's good. So, what have you heard about geomagnetic storms?
Geostrophic wind?
No. Geostrophic storm. I mean, geomagnetic storm.
Is that in your, what did you say? Is that in your itinerary?
I got them.
What?
Schedule.
Is it what?
It's going to be in my Amazon cart pretty soon.
I mean, geomagnetic storm.
I don't know. You're going to have to teach me this.
Well, just like geostrophic winds, the answer, my friend, is blowing in the wind. Because we're going to be talking about solar winds. Now, what is solar wind? Solar wind is a stream of charged particles released from the upper atmosphere of the sun, called the corona, and it's made up of electrons, protons, and alpha particles.
Ooh.
They still haven't gone to their beta yet, so it's not a wide
Well,
release.
gamma particles, gamma rays.
Gamma rays. Once they're ejected in a thing called a coronal mass ejection, they travel at high speeds towards the Earth. And they can actually take up to a couple days to reach our
Wow.
planet, which is actually relatively slow on space terms, since light takes it a little over 8 minutes to get here. But still packs a big punch if it does hit the planet. These solar winds actually go in tandem with the cycle of the sunspots on the sun. So if we have more sunspots, we tend to have more activity in this regard as well, and geomagnetic storms if it does reach the Earth. Now, what happens is that these solar winds exert a pressure on the Earth, and if it actually reached the Earth's atmosphere, it would actually strip it away because it has so much power accompanying it.
Do we see this in like high pressure on the planet?
We actually don't, Chris, but I like your enthusiasm. So what we actually see here on Earth is if it does hit our upper sphere, is we will see Aurora Borealis, or the alternative in the south, which I actually don't remember the name of. But what happens here is that when these charged particles reach the top of Earth's magnetosphere, which is pretty much formed by the churning of iron in our core, what happens is that they spiral around the field lines that churning creates, and they bounce back and forth very quickly to both poles. And when this happens is that positive ions will drift towards the west, and negative will drift towards the east. And when this happens, they actually will penetrate the ionosphere and collide with the atoms up there, and will create what we see with the aurora. So this interaction with the ionosphere is what creates those wonderful lights that we like to take pictures of.
Can I read at night with these? Like, are we going to see some in Albany?
Not in Albany, if we're lucky. Because if we do, then we have bigger problems at hand. And we might even need a bigger boat. So now, we've talked enough about solar wind and what it can kind of do. The crash course version. But what happens if we have a very intense solar storm? Where it like what would it do? Like, we haven't really seen it in modern times except, before the digital age. So what can we learn from some of these actual examples and see what would happen if it did happen today? So for now, let's talk about the Carrington event, which happened in 1859. So James Buchanan is president, MySpace is still dead as ever, and this storm happened. So what happened was that we had this large solar coronal mass ejection, as I mentioned before, hit the Earth's magnetosphere and induced this large reaction that we talked about with the aurora. And what happened is that it was so intense, it was the largest one on record, that they actually recorded seeing these northern lights, as they're also coined, as far south as the tropics, the took about 17 hours to actually traverse the distance. And when it did, it was first noticed when bright colors started to actually fill up the sky over New England. And this pretty much coincided with the buildup before the peak of the solar spot cycle. So it was a couple months prior to that peak. And this was late August. A couple days later, in northern Queensland, in Australia, they started to notice the aurora in the sky at night. And this is insane because Queensland is near the tropics, or part of it is in the tropics, up in the southern hemisphere. So that means that the aurora are stretching all the way up to the tropics, which is you need some intense radiation to be able to do this. So the reason it's called the Carrington event is because it was first recorded by astronomers Richard Carrington and Richard Hodgson, both independently on September 1st. So they weren't working together. The second guy clearly might be a little bitter that it wasn't named after him.
I'd be bitter.
Yeah, I think we all would. So pretty much what happened is that from September 1st to September 2nd, a lot of these geomagnetic storms were recorded around the Earth, where we saw auroras as far south as Colombia. There was one report that some coal miners out in the Rocky Mountains actually woke up and started cooking breakfast in the middle of the night, thinking that the sun was rising, and they were preparing for a new day to start mining gold. Also in the Northeast, it was reported that you could actually read a newspaper by the light of the aurora at night. And as I mentioned, some other locations such as Hawaii, Cuba, and other parts of the tropical Atlantic and Pacific were able to record seeing the northern lights. So it's very rare, if almost impossible in most cases, to see it at our latitude. But it's once in multiple centuries to see it down in the tropics, if even less frequent than that. So definitely intense. So it actually, as you may know, this was during the early part of the Industrial Revolution. So we actually had telegraph systems by this point. That's pretty much the quickest way of communicating at the time. And what happened is that when this geomagnetic storm was happening, it actually caused most of the systems to fail across North America and Europe. And in some cases, it gave shocks to the operators at the end of it, just because it just infiltrated the lines. So that's some intense.
That is intense.
Talk about shock value. So after the 2 days had ended and things were starting to go back to normal, on Saturday, September 3rd of 1859, there's actually this column I found in the Baltimore American Commercial Advertiser, which is a paper that I bet you're subscribed to still, right?
I don't think so.
Really?
I don't do newspapers
get
anymore.
Get your shield to protect radiation and get this newspaper.
With newspapers.
Yeah. So this is word for word what was in that column on September 3rd. Quote, "Those who happened to be out late on Thursday night had an opportunity of witnessing another magnificent display of the auroral lights. The phenomenon was very similar to the display on Sunday night, though at times the light was, if possible, more brilliant and the prismatic hues more varied and gorgeous. The light appeared to cover the whole firmament, apparently like a luminous cloud, through which the stars of the larger magnitude indistinctly shone. The light was greater than that of the moon, and at its full, but had an indescribable softness, indelicacy that seemed to envelop everything upon which it rested. Between midnight and 1 o'clock, when the display was at its full brilliancy, the quiet streets of the city, resting under the strange light, presented a beautiful as well as singular appearance." End quote. So that was the report from 1859.
Wow.
Yeah.
That was an incredible William Shatner impression, by the way.
Were they pirates?
Indescribable
I don't know what was
softness.
going on.
They started okay, they were pirates in the middle, and then they got back off the boat.
The light was greater than that of the moon.
So actually, real quick, just to end real quick. So fast forwarding to 2012, MySpace was already dead by then too, so not much has changed.
Nothing changed.
But what did happen is that there was a very similar magnitude of a geomagnetic storm that occurred in 2012. And what happened is that it actually passed through Earth's orbit, but it missed it by 9 days. If it was 9 days, I'm not sure if it was before or after this event, but if Earth had moved, we would have gotten a direct hit. And if that had happened, it would probably cause much more severe travesties than your telegraph being shut down for a bit. It probably severely damage a lot of our satellite communication, our transformers, our Bumblebee,
GPS.
something. Yeah.
GPS would be.
Yeah, GPS would be wrecked. There's a whole lot of stuff that's really interconnected with this electric stuff nowadays that, honestly, I'm not sure how much we're actually prepared. I'm assuming, or I'm hoping, that at least the electric grids and so forth are prepared, because if not, it could take months to like actually get it back together. But other than that, yeah, we forget how much we depend on the sun, besides getting a nice tan in the sun. Right, Chris?
Sometimes sun is like the little brother, the older brother, I should say.
It should be the older brother. Yeah.
The older brother is the one that pranks the kid. You can think of the sun as the sun of the galaxy, the older brother of Earth. And, sometimes these solar storms, they just do damage, a lot of damage. So
That's intense.
it's really intense.
No, that's a lot of damage!
That's a lot of damage.
What was that analogy?
It's a family tree that's
The galaxy is
No, but sometimes the older brother, the sun.
Yeah, he's trying to
shine.
put the sun as being Earth's little brother, but I'm like, there's no way that's true.
No.
But it's the sun of the galaxy.
The sun is Earth's older brother, and the galaxy is the parent that tells them the.
Earth, sun.
No.
Just chilling.
We don't know how they reproduced. If that's what you're getting into, go to our biology spin-off.
Biology, astronomology, maybe.
Astronomology? You talking about astrology or astronomy? Or astronomology? House of the Moon.
Sean, that really brightened up my day. Almost as much as an aurora borealis.
Wouldn't that brighten up your night?
It's true. Maybe the sun will brighten my day. So, just to recap what we talked about on the weather booth, I talked about the sun and it being large and warm, and its effects on the Earth.
And I talked about solar wind, geomagnetic storms, and I recapped an event that happened in 1859 that allowed for gold miners to start breakfast early.
Thanks for tuning into the weather booth this week.
I'm Sean. This is Chris, and this has been the weather booth. Thank you for watching.
There is a house in New Orleans they call the rising sun, and it's been the ruin of many a poor boy, and God, I know I'm one.